In this video for section P5, we're going to talk about some different factoring types. These include factoring out the greatest common factor, factoring by grouping, factoring trinomials, and difference of squares. So our instructions are to find the missing pieces needed to make the equation true. So let's look at number 1. For this one, what we're going to do is distribute the 5x into the set of parentheses. We know that 5x times 2x is 10x squared. Because 5 times 2 is 10, x times x is x squared. 5x times 3 is 15x. Now what we're going to be doing in this activity is thinking about going from the right side of the equation to the left side. How could we take something that's already multiplied out and put it into parentheses? So looking at number 2, we have a set of parentheses that's 2x plus 3, and we need to figure out what would go on the outside. So to do that, I can think about 2 times what gives me 18? Well, that has to be 9. And x times what gives me x to the third? Well, I need to multiply by 2 more x's, or x squared. Then I can check that with the second term here in the parentheses of 3. If I multiply 9x squared times 3, I get 27x squared. So that checks out. In number 3, now I'm trying to find what's on the outside and what's inside the set of parentheses. So in order to do that, what I need to think about is what number can both 10 and 4 be divided by? That's the largest number that both 10 and 4 can be divided by. Excuse me. So 10 and 4 can both be divided by 2. Then for the x's, I have x to the third and x squared. So the largest amount of x's that I can take out is 2. So x squared would go on the outside. Now I think about, what do I multiply by 2x squared to get 10x to the third? I need to multiply by 5, and I also need to multiply by x, because I need one more x to get to x to the third. Then for the second term, we have 4x squared. What do I need to multiply in order to get that? I already have the x squared, so I don't need any more x's. 2 times what would get me 4? That would have to be 2. So a 2 goes here. Then I can check that by multiplying it out and making sure that I get back to what I started with. Let's look at number 4. So for this one, we have x squared and we have plus 5, and they're both multiplied by x plus 3. So what goes on the outside here isn't a single term like it was above. It's going to be this set of parentheses, x plus 3. Number 5 is going to be kind of similar. So we have x minus 7 as a common factor in both terms. And then for the other set of parentheses, it's going to be the pieces that are left after factoring out x minus 7, which is going to give me 2x plus 3. For number 6, now we have to do a little bit more work, because we have to get it so that we have these two same sets of parentheses. So looking at these sets of parentheses, they aren't the same, but I can think about what I would put on the outside. So for this first set, we have x to the third plus 4x squared. So I can take an x squared out of that set of parentheses, and that leaves me with x plus 4. In the second set, I can take a 3 out of both of these terms, which leaves me with 3 times x plus 4. Now that I have the same set of parentheses, I can factor that out. So one of my factors is going to be x plus 4, and the other one is going to be these leftover pieces, x squared plus 3. Now, notice that some of these I have signs filled in, like in this number 5, I have a minus sign filled in here, so the x minus 7 had to go in this one. For number 6, they are both plus, so it doesn't matter which one I write first and which one I write second. And for that matter, for number 5, I could write x minus 7 times 2x plus 3, and that would also be correct. So the order of the sets of parentheses does not matter, because multiplication order doesn't matter. So looking at number 7, now we're going to go through the same process. We just don't have the parentheses that we had above, but we're still looking at the first pair of terms and then the second pair of terms and thinking about what we could factor out. So in the first pair of terms, I can take out an x squared, and that's going to leave me with x plus 5. And in the second set of terms, I know that I want to have x plus 5, so what would I need to take out? Well, I would need to take out a minus 2. So remember that when you have this minus 2 here, that's going to distribute into both of these and make them both negative. So I know that if they're both negative, I need to have a minus 2 on the outside. So we have x plus 5 times x squared minus 2. And this technique that we developed in questions 4 through 7 is called factoring by grouping.